Hello, welcome back. Well, I told you I'm going to do some two interesting typical examination type of questions. I've written this question to save time, so I'll read through it, and I need to show that I'm putting salient points there: x-axis at A, y-axis at B. Show length AB independent of T, because I'm going to rub off. Let me read through the question. An asteroid has equation x equal to cos cube t, y equal to 4 sin cube t, x equal to 4 cos cube t, y equal to 4 sin cube t, where t is a real number. Okay? Show that the equation of the tangent to this curve at any point with parameter t, that means you do not know the value of t, so dy by dx will be in terms of t. Your x coordinate is 4 cos cube t, your y coordinate is 4 sin cube t. That's what the question says. Indirectly, if no value of t is given, remember, to find tangent or normal, you need an x value and a y value. The x value will be the parametric equation of x with t, y value will be the parametric equation of y with t. Okay, so the expression. Then they say, show further that is the tangent meets the x-axis at A. That the tangent, it meets x-axis at A, it meets y-axis at B. Find the length AB, show that it doesn't have a t independent of t, and find that length. Do you understand the question? This is a typical A-level question, A-star level question, or a high A-level question. So let me rub it off because I've got all that. I need to now show that the tangent is that. So what you do is, you know x value, you know y value. So the point is 4 cos cube t and then 4 sin cube t. I have made up this question, so there could be errors when I work. We will see. Remember, I told you I cannot use past paper question directly because it's copyrighted. Yeah, and I can't use a textbook question directly because it's copyrighted. So what I'll have to do will be make up my own question based on the same thinking. Yeah, all right. So dx by dt is 4 times onion rule or chain rule. Call u equal to x equal to 4u cube, u equal to cos t, but I'll do it directly. This is cos t the cube. So first differentiate the cube, you get 3 cos square t, then differentiate the cos, I get minus sin t. dy by dt equal to 4 times, first differentiate the sin cube, I get 3 sin square t, then differentiate the sin, I get cos t. Divide one by the other, so dy by dx equal to 12 sin square t cos t divided by minus 12 cos squared t sin t. Well, 12 and 12 cancel, cos and cos cancel, so I get minus sin t over cos t. Look, I know you're a very clever person. You're a very clever person. So I know, sir, sin and cos is tan, so I'll use tan. I won't. Can you tell me why? The answer is in terms of t. The answer is in I forgot to turn on the always. I think I'd spent about 3 minutes. This one. Answer is in terms of sine and cos, so don't change it. So what is the tangent? Y minus y1 equal to gradient times x minus x1. Whoops, so let's cross multiply. Y cos t minus 4 cos t sin cube t equal to minus x sin t plus 4 cos cube t sin t. Everything is in terms of t. Okay. So I can bring the x to the left. So x sin t plus y cos t equal to 4 cos cube t sin t plus 4 sin cube t cos t. I can remove 4 sin t cos t common factor. I can write it as cos squared t plus sin squared t, which happens to be 1. So that is 2 times 2 sin t cos t, which is sin 2t, 2 sin 2t. You have proved the first part. So if you know value of t is given, just assume the point to be the parametric equation, find dy by dx into of t or theta, and then do it. Yeah? Good. Having done the first part, that carries about 5-6 marks. I've got the next bit to do. This tangent cuts the x-axis at A. So in other words, if you have this, maybe the tangent is like this, it cuts x-axis at A, y-axis at B, find the coordinates of A and B. So at A, y equal to 0 in tangent. This is where you have to use your common sense. If y is 0, got a sin t, so use this instead of 2 sin 2t. So x sin t equal to 4 sin t cos t. So x equal to 2 cos t. So the point A is 2 cos t 0. At B, x equal to 0. So that gives me y cos t equal to 4 sin t cos t. So y is equal to 4, not 2. That's 4. That's 4. Y is equal to 4 sin t. So B is 0, 4 sin t. What is the distance AB? Is square root of 4 cos t minus 0 whole squared plus 0 minus 4 sin t whole squared, which is 16 cos squared t plus 16 sin squared t under root, which is 16 root 1. Oh, so root of 16 times. Okay. Root of 16 times cos squared t plus sin squared t, which is 4 independent of t. And you must find the value. So whatever might be the tangent, remember I didn't know the value t. See, that's the beauty of it. So if you have your asteroid like this, yeah, wherever you draw a tangent and wherever it cuts the x and y axis, the length of that bit cut between the two axes of any tangent is always 4, irrespective of which point you're taking on the graph. Very interesting, isn't it? Good. Okay. So that has taken about 8 minutes. So what I'll do is, I will call you, you will not know, I will start the lesson after I write the next question. So I've written the next question and I have brought you back. Find the equation of the tangent and the normal to the curve. Okay. X equal to 80 squared, y equal to, I will change it to the parabola. To the parabola, x equal to 80 squared, y equal to 280 at the point P with parameter t. Okay, we can do that. The tangent at P cuts the x-axis at the point T. The normal at P cuts the x-axis again at the point N. Find the length of Pn, find the length of Pt, show that it is 1 over mod T. Because we're talking of lengths, we put a modulus sign. Let's go through it systematically. So x equal to 80 squared, y equal to 280. So the point P is 80 squared 280. Yeah, good. So dx by dt is 280, dy by dt is 2a. So dy by dx is 2a over 280. So dy by dx equals 1 over t. Let me write that here. So dy by dx equals 1 over t. So what's the tangent? Tangent is y minus 280 equals 1 over t times x minus 80 squared, or ty minus 280 squared is x minus 80 squared. So therefore, I'll write the equation of tangent here. So tangent is ty equal to x plus 80 squared. Yeah, straightforward. 2 marks each. 2 marks for dy by dx, 2 marks for tangent, 2 marks for normal. Okay, so normal is y minus 280 is minus 1 over dy by dx times x minus 80 squared, which is y minus 280 equal to minus t times x minus 80 squared. Y is equal to minus xt plus 80 cube plus 280. Let me write that as well. So normal is y is equal to minus xt plus 80 cube plus 280. Brilliant. First part of the question is done. Now is the interesting bit. I will leave that bit there because I don't know whether we might need it. So look, at t, the tangent at p cuts the x-axis at t. That means in this tangent, I put y equal to 0, I get the x-coordinate of t. So at t, y equal to 0 in tangent. What happens when you put y equal to 0 in tangent? X plus 80 squared equal to 0. So x is minus 80 squared. So the point t is minus 80 squared, 0. At the point n, the normal cuts the x-axis. So in the equation of normal, I put y as 0. At n, y equal to 0 in normal. So what do I get? Minus xt plus 80 cube plus 280 equals 0 divided throughout by t. So x is equal to 80 squared plus 2a. So the point n is 80 squared plus 2a comma 0. Is that clear so far? Of course, t can be negative. So later on when I find distances, in the end, we can put a modular sign. So I have found the point t, I have found the point n, that's why I left it there. Now, I am asked to show the length of Pn divided by the length of Pt. What is Pn? How do you find length, the distance between two? x2 minus x1 whole squared plus y2 minus y1 whole squared. Yeah? 80 squared and 80 squared cancel. I get root of 4a squared plus 4a squared t squared. So that is 4a root of 4a squared times 1 plus t squared. So it's 2a root 1 plus t squared. Correct? Very good. Let's find the length pt. Pt is square root of minus 80 squared, the whole squared, plus 0 minus 280 the whole square. Minus 80 squared minus 80 squared is minus 280 squared. When I square it, I get 4a squared t power 4 plus 4a squared t squared. I can remove 4a squared, t squared as a common factor. I get 1 plus t squared. T squared plus 1. Okay. So you got it wrong. Okay. So when I take the square root, I get 280 root t squared plus 1. So what is Pn divided by Pt? Is 2a root 1 plus t squared over 280 root 1 plus t squared, which gives you 1 over t. I put a modulus because t can be negative and distance cannot be negative. That bit I think carried 6 marks. The first bit carried 6 marks. That's how the question is very interesting and quite demanding, right? Hang on. This is the difference between A star and A. Yeah, by doing this, you can get your A and perhaps A star. But maybe by thinking, look, I'm doing it, so I know what to do. I do like this and I gave you the logic. But for you to think out of that logic in the examination is going to take more time. So maybe you might know some question, you may not be able to do it because this question was too long. But if you think for a minute, I don't need any of these. In fact, I don't need to find n, I don't need to find t. I can still get the answer. Sir, how is that possible? How can you find without knowing n, without knowing t? How will you find distances? You know, it's a parabola. When t is 0, x is 0, y is 0. When t is 1, x is 1, y is 2. When t is minus 1, x is 1, y is minus 2. So the graph is like that. That's a point P somewhere there. 80 squared, 280. Yeah? Now, the question said, you drew the tangent at P and it cut at T. Correct? And it also said, you drew the normal at P and it cut at Q. I need to show that Pn over Pt equals 1 over T. Isn't it? That result. Suppose I have to call this angle as theta. What is Pn over Pt? Is tan theta. Correct? Now suppose I have a line y equal to mx plus c. Yeah? Change in y over change in x is what? Is the gradient m. If I call this angle as theta, don't you think the gradient is tan theta, which is gradient of tangent, which is 1 over t. What is simple diagram. Can do it in 2 minutes. Yeah, there's nothing wrong in the way we did it. It says find the equation of the tangent. Yeah, this you have to find, that you have to find, I agree. But if the question just said, if the number, it doesn't say this. It just says the tangent at the point P to this curve, cut the x-axis at this point, cut the y-axis at this point, show that. Then you don't need to do any of these things. Of course, you would analyze, oh yeah, I need to find the equation of tangent, find where it cuts. Equation normal, where it cuts. Then, but it's okay, there's nothing wrong with that. But I remember this question way back in the 80s, and unfortunately, since then, almost every year, I ask this question towards the end to my further maths and math students. every year I come across only one person who thinks like this and gives me the answer. The remaining boys and girls will all get the correct answer. Some of them don't, they struggle because not very good at parametric equations, but majority of them get the answer. They go through the whole process. That is thinking outside the box. Yeah? Good luck. That finishes parametric equations. Have a nice day. Bye-bye. Hello. I want to take this opportunity to propose a vote of thanks. I would like to thank Vivid Innovations Private Limited and Commerce Forum for so generously giving up their studio and the facilities and the services of their technicians to record all these videos for free. I think that needs to be acknowledged and appreciated. Thank you very much. And my special thanks to Mr. Nitin Mahadevappa, Mr. Nishant Guruswamy, and Mr. Sadan Kumar DN for all their help and assistance in getting these videos ready, uploaded and launched. Thank you very much.